This will take up an hydrogen and it will form a electropositive center. Hello everyone, welcome back to our another class, and today's topic is aromatic compounds. So let's start. Now when you come to the first problem, the first problem is pretty basic. All the hydrocarbons shown are very weak acids. We all know that. One, however, is far more acidic than the others. Which one is the strongest acid? Hence, one of these will release an hydrogen ion to form a carbon ion, which will be stable. So that carbon ion must be an aromatic compound. Now, if we compare this is obviously stable. This does not require any removal of hydrogen. This one, even if this or the, we have to remember that no sp2 hydrogen will be removed. So we have to remove sp3 hydrogen. So here in this case and here in this case, but both in this case, the complete delocalization will not occur. And also in this case, there is 6 double bond. There is a 5 double bond actually, and if this hydrogen gets removed, this will form total of 12 double bonds or 12 pi electrons. Now we all know that 12 pi electrons mean anti-aromatic compounds, so it will not be stable. That leaves this compound. Now this has already 4 pi bonds, that means 8 pi electrons, but due to the non-delocalized structure, this is a non-aromatic structure. But if in this compound the sp3 hydrogen is removed, there will be a negative charge and there will be total of 10 pi electrons, and there will be a complete delocalization like this. So this will be aromatic, and both the ring will be aromatic in this case, and hence this hydrogen will be most acidic, making the compound C the most acidic compound. Okay, this is how we can solve this type of problems. Now the next problem. Now this is, we can see this is AlCl3. So AlCl3 generally gets used in Friedel-Crafts acylation and Friedel-Crafts alkylation reaction. So this must be an example of Friedel-Crafts acylation and Friedel-Crafts alkylation reaction. How? Well, this compound, the AlCl3 will be acting as a Lewis acid. So this oxygen will be positive, and hence the benzene ring, the carbon will attack this carbon, and this bond will be removed, forming, and due to the H3O plus, this C double bond of O minus will be converted into an acid. So the compound will be like this. It is a very simple reactions like Friedel-Crafts acylation. Now this will be the compound. Now this will be our compound A. Now in compound from A to B, there is zinc amalgam and HCl. Zinc amalgam HCl is a reducing agent which reduces the CO double bond into CH2. So compound B will be like a CH2. So this will be our compound B. Now and again this SOCl2 turn that C double H group into a COCl group. And COCl in presence of AlCl3 will undergo another Friedel-Crafts acylation to give a compound like this. So this will be our final answer, and this is B. We can clearly see this one. So B is our correct answer. So this is just, the structures may look scary, but this is just a simple case of Friedel-Crafts alkylation and Friedel-Crafts acylation reactions. Okay. Now the next problem. Now we all know that there in aromatic compounds electrophilic aromatic substitution occurs. That means the most electronegative center attacks the electrophile. In this compound, if we can see, there are two places which is the most electro rich. Which one? We can clearly see that the double bond, the lone pair of nitrogen can delocalize like this, making these two positions the most acidic. Making these two positions most electron rich. Now, so electrophilic aromatic substitution will take place either in these two places. But here in this ring, there is another additional CH3 which adds plus I effect to the ring. Hence, this position is more electron rich than this one. So, option 1 or option A will be our correct answer. Okay, this is a very simple question. In aromatic compounds, you will tend to get very simple questions like this. Not much difficulty will arise from here. Okay. Now coming to this problem, what happened out there? This does not look familiar, but this is an example of Friedel-Crafts alkylation. The first reaction is a Friedel-Crafts alkylation. How it will occur? This will take up an hydrogen and it will form I electropositive center. Then this electron will attack the electropositive center to form this type of compound. Or we can write it like this. Okay. Now with NBS, we all know that NBS prefers any benzylic or allylic position for bromination. Now this is a benzylic position, so the Br will attach to this one, and upon treatment with alcoholic KOH, this Br will be eliminated, forming a double bond like this. Okay, so this compound will be our A and this will be our structure B. Now on this treatment with the organic peroxide, what will happen? We all know that any double bond treatment with an organic peroxide will form a epoxide like this. So this bond will form an epoxide. So there will be an epoxide like this and a benzene ring attached to it like this. So we can see which one is the correct answer. You can see this is the correct answer. Now this pH is written here deliberately to make you confused. So if you can write the structure a little bit of differently like this, so you can now see that the structure B and this one is the same structure. So B is our correct answer. Okay. Now if we come back to the last questions for today, which is that scalene C7H6 is fairly polar aromatic molecule. So which of the resonance structure will be the most contributing? Now the most contributing resonating structure has many conditions, that it must have the maximum number of covalent bonds or the position of the charges, but the most contributing factor in this case will be the aromaticity. Now if we can draw this structure, we can see that none of this ring is presently not aromatic. But if we remove this double bond and shift the electron pair to this carbon, it will form a compound like this. So here will be the minus charge and here will be the plus charge. Now you can see this ring becomes a 6 pi electron system, that means an aromatic, and this becomes a 2 pi electron system, also aromatic. So in this structure both the rings becomes aromatic. So this structure will be the most contributing resonating structure, and among all the forms we can see that the D resembles this structure. So D will be our correct answer. Okay. So if we study aromaticity, we can expect questions like this. But obviously, there are other questions from aromatic compounds such as from reaction chemistry, which we have all discussed in our previous classes. So we will restrict ourselves to today only to aromaticity, or mainly aromaticity. Okay, I hope you like the video, so please drop a like and please subscribe to the channel. Okay, and the exam is all around the corner, so all the best to you students, and thank you.